Hi, everyone. I'm Drew McDaniel. I'm a lead program manager in the Windows Azure team. And today we're going to talk about a pretty exciting topic, how to use Windows Azure and the power of the cloud and the number of machines in the cloud to bring to bear on your dev and test and lab environments. We'll really talk about how you can actually utilize Azure to get some benefits when you need machines. And for those of you that are using MSDN, these may be things that you already have in your subscription, and you can leverage those and put those to use right away. So just a quick show of hands. I'm curious, how many people are using either Windows Azure for platform as a service or virtual machines today? Excellent. And how many of you guys have activated your MSDN benefits to get the free Azure subscriptions? Some. Okay. So we'll talk about that today. We'll talk about how to actually leverage that. Also, I will preface this going forward. As I was talking to some folks, there's myself and another colleague of mine did a very similar talk in TechEd. If you attended that session, this is going to be fairly similar. So there's a lot of other great sessions going on. And so if you had already participated in that session or watched that session online, you might want to look at some other things going on so that because the content is going to be very similar. So today we're going to focus on Windows Azure. We're going to look a lot at the compute aspect, our platform as a service, our infrastructure as a service. My history, my background has been working on our infrastructure as a service release that was put into general availability in April. But we're also going to be talking about how you can use infrastructure as a service with platform as a service together. When you think about the MSDN benefits and the dev test, you actually will probably be using both of these. We'll also touch on storage and networking that really go hand in hand with any of the virtualization that we do in Windows Azure. We'll drill into the details of infrastructure as a service and our virtual machines. Talk about some automation. A lot of times as you're looking at this, the key thing is how do I automate this? How do I move from from a staging environment or test environment into production? I heard that a lot talking to some of you folks as you came in, so we'll touch on that. Talk about the networking options and how the networking can be used to simplify your network, to simplify the use of Azure, and really make Azure like the machines are in your on-premise data center. And then again, how you put that all together to really make Azure your sandbox, to bring the power of the cloud to your problems, to really help Azure allow you to rule the world. So in Windows Azure, we really have 6 principles that we think about. The first is the economics and the usage-based billing. This is a big change, this is a set of announcements we've announced recently around paying for only what you use all the way down to the minute. Some competitors charge at an hour basis. We charge you at a minute, and when you're thinking about with dev test, this can be really advantageous. There's also some other application models where only charging at a minute granularity can really be useful. Azure itself is thousands and thousands of machines that allow for a very easy, very elastic scale. As you want to leverage those and control those, especially in a dev, test, or lab type environment, you really want a lot of automation. And we'll talk about the automation that is in place today using existing tools and existing scripting environments so that you can really leverage that power of the machines in a very seamless, automated way. And then for anything, when we're thinking about a large set of machines, the ability to have it always on, high availability. We'll talk about how Azure does this. We'll drill into how it affects the virtual machine, our infrastructure as a service, which is a little different than our platform as a service, but how Azure gives you that high availability and load balancing across your instances. Now, as level set, when we think about compute, there's really 3 types of compute that people normally think about or that we hear a lot. On-premise is where you own and you manage everything, from the hardware to the operating system to the application. A lot of times leveraging tools like System Center tools, or if you're running virtualization on VMware, the tools, but you're managing the whole stack. Then Windows Azure, up until the infrastructure as a service, we provided the platform as a service. Well, we manage the entire stack up to the application. So you provide the application, we put it on a machine, the machine is stateless, you connect to your different data sources like Windows Azure Storage, Windows Azure SQL Database, and you just worry about the application. But then we brought online in April, we released into general availability our infrastructure service. And this is really mixes right between the on-premise version and the platform as a service version that allows you to do some things that just weren't available before in Azure. So I want to drill down and look at those two a little bit more. So infrastructure as a service gives you more flexibility than you had in the platform as a service. The platform as a service gives you a lot more ease of automation and things a platform does for you. But with that flexibility on infrastructure as a service, it allows you to bring your existing applications. So you can bring your Active Directory from on-premise and just run it in a virtual machine, the on-premise version of SQL Server or SharePoint, and run those in a virtual machine. When you think about infrastructure service, one of the common statements that have been said around Microsoft is if you require a developer to change the application, it's not really infrastructure as a service. A lot of times the developer, you're going to be rewriting applications for platforms as a service, and infrastructure as a service is what gives you that temporary thing where you can use your legacy, your existing application, put it in the cloud while you move to platform as a service. Finally, you also have the ability to use a wider variety of underlying operating system. Because you manage the operating system in Windows Azure Infrastructure as a Service, we allow you to bring things like not only Windows, but also Linux and other OSs there. And so you have a wider variety of application because it's really just a virtual machine. We use the we use the Hyper-V as the underlying infrastructure platform, and so the set of different virtual Linux versions that are provided by Hyper-V and supported by Hyper-V allow you to bring those to Azure with some limitations, and specifically this is around Azure's focus on 64-bit operating systems, so it's only the 64-bit versions. And we have those in the gallery so you can really get started very easily. So with infrastructure service, and so this will cover some of the high level of infrastructure service. I know some of the folks have been using the infrastructure as a service for a while. Some folks are fairly new. The first thing is infrastructure as a service allows both a developer and IT pro experience. The platform as a service starts off in Visual Studio. We'll walk through some of that stuff and how you use that in platform as a service. But infrastructure as a service gives you a very easy way to approach the system. We have a management portal that we'll look at, as well as a set of scripting environments. Both of the management portal and the scripting environments are built on that REST API layer. And so if you so choose, you could rewrite PowerShell for Azure. You could rewrite the entire management portal on top of that REST API structure that we have available. And so it gives you that flexibility of either coding at a scripting level or going down into automation right at the REST APIs. As I mentioned, when we looked at infrastructure as a service, the applications were key. Getting the right applications running. On the Microsoft stack, SharePoint was one of those applications that really was not only something customers were really asking for and wanting to make sure that worked, but also rounded out and validated the entire stack. Because SharePoint requires Active Directory, requires a set of networking capabilities, requires SQL Server. And so to a large extent, on the Windows side, what we had looked at and said, if SharePoint works and works well, then we're going to consider the first release of infrastructure service as a success. And so that's what we'll see, and as we go through the talk, some of the automations and stuff like that, we've actually used SharePoint as the example that we start with, because building out SharePoint is both tools that you can use for other applications, as well as using SharePoint directly. In the slides here, you'll notice the items that are bolded and underlined. Those are the images that are available in the platform directly as platform images. The other images or the other versions are ones that are tested and supported on the platform, but we don't have the image directly. Those you can either install on an existing virtual machine, or you can bring your own image up to the platform. So that actually goes into a great point, which is with Windows Azure, the Microsoft applications, you're going to see a little bit of difference than you're going to see running Microsoft applications on some of the other cloud platforms. It's because all of those applications are tested heavily in Windows Azure. In fact, at Microsoft, we have a thing called our Common Engineering Criteria. And for server workloads, as of fiscal year 2013, a requirement is that they validate those workloads on Windows Azure, make sure that they work well, and then any place where there's issues where they don't work successfully in Windows Azure, that they're clearly documented. And so you'll see this in these apps in the stack that we'll talk about today, have all been heavily tested in Windows Azure, and a set of documentations on how to use them best in Windows Azure. So SharePoint, SQL, if you go to the Azure portal and we'll look at that, a large number of versions of SQL, mixing from 2008 R2 version of SQL to 2012, up to the most recent release, which is the CTP release of SQL 14. And then we have multiple versions, multiple underlying operating systems where we have SQL installed. So like I said, we have a set in the gallery, and you can bring others to Windows Azure. What is useful to point out is the licensing. So if you're doing production, and we'll talk a little bit how it's a little different on a test environment, when you're doing a production deployment, the licensing when you use one of the released versions of SQL from the gallery and the platform, you're paying on a per hour basis for the SQL Server software. If you have a license on-premise, that license is available for license mobility, which is effectively if you have a software assurance associated with that license, you can bring that to the cloud. When you bring that to the cloud, you're not paying per hour. You're just using your existing license. And so it's a key thing to remember that for production workloads, when you deploy the one in Windows Azure, it's your Windows Azure, you're paying for the license per hour. If you don't want to pay per hour, if you're using existing license, you need to bring that and install that on one of the base virtual machines, the base OS virtual machines. And then we have a set of other applications. BizTalk is one of the key ones that's also in the gallery, also heavily tested. Also, as I mentioned, SQL 14 and Windows Server 2012 R2, the preview release, is also in the gallery. One other item that is not on this slide that just recently went up is we also have a version of Visual Studio 2013 running on Server 2012 that is also in the gallery. And so that's a preview version. You can spin that up and get a copy of Visual Studio running in Windows Azure. Now, when it comes to Windows Azure, one of the things that's really important is that we didn't, especially when it comes to virtual machines, we didn't build a new type of storage system. It's not a different block storage system. It's the same Windows Azure storage system that is used for our existing platforms and service workloads. We use the Windows Azure blobs to store VHD files. And what this means, one, is by being a VHD that is compatible with Hyper-V on-premise, allows you to move things to the cloud, back to on-premise, very easily. You can take your machines, and that can be your OS or your data drives, and move them between the cloud. And it's all because the cloud is using the Windows Azure, the Hyper-V 2012 is the underlying hypervisor in the cloud, and so that VHD format is supported natively. Also, when you're running the virtual machines, and so if you're running the infrastructure service, your disks are stored in Windows Azure storage. Now, what this means is, one, you have the data stored on 3 individual disks, and so you have very high reliability and durability of the data. But also is you have a huge number of spindles. So in the back end of Windows Azure storage are thousands upon thousands of disks. And so that as you use your VM and as you hit the data drives hard, so if you're doing a SQL test, you will actually see your performance improve as you hit it because the back-end storage is detecting the usage pattern and it's spreading it out across different spindles. And so it's if you're doing any kind of a load testing in Windows Azure, you want to make sure to do a warm-up on the database side of things. For about 45 minutes is what it takes for Windows Azure storage to do its full splitting across the multiple different partitions that it will split it across. This also ensures that if somebody else on that same disk that you're running on starts hitting their data hard, the Windows Azure storage will move that around to spread the load, and so that you don't have a noisy neighbor problem. So let's move in. We'll talk about a set of demos here using Windows Azure storage. So what I've got here, and so when it comes to managing a lab environment, snapshotting things, moving things around, when you're looking at the virtual machines, it is important to understand how the storage is handled in the back end, because that's one of the key points about moving the machines from a production environment, from a staging environment to a production environment. So I've got a machine here that we're looking at. We're going to the snapshot test machine. And this machine is set up, and it has one OS disk and one data drive. And so those two drives are then stored in Windows Azure Storage. Now what we've got here is this is a third-party tool called Cloud Explorer. We're looking at the container for the VHDs here, and those two machines are stored here as a snapshot test. And if you notice, let me resort this. If you notice, the machines, the images are being written to as we speak. So for example, here's the OS drive, and it's being updated very recently. The data drive, you can see, is not being written to. So if we go to the machine itself, we'll flip over, and here we have 3 disks. Now it's important to recognize that there's the OS disk, the data drive we've added here is drive E, and then there's this disk called D, labeled temporary storage. That is a drive that is resident on the hypervisor, on the physical machine. It's a scratch drive. And so you want to be careful, and you use that as a scratch drive. It is fine. We put the page file on there. But you don't want to put your data on there that needs to be durable. So for example, if you're running an Active Directory, don't put your Active Directory database on the D drive, because in a service heal scenario, when you shut down the machine, that drive will be reset. And we'll show you that in a minute. So the data put on D does need to be something that is temporary and you can recreate. So if we look here, and let's just go ahead. I've got a machine here on E drive, and we'll look at Azure VMs from build. And if we save this, we'll flick back over. And we'll see that the writes are flowing through to the backend storage. Now your data drive, you do have the flexibility. You can select it to be no caching or read caching or read-write caching. Except for some very rare instances, we normally recommend you want to start your data drives stay with the no caching because the backend storage has all those spindles. It's the general purpose way to go. If your application does read caching and your data set is fairly small, you can turn on read caching on that data drive. The thing you want to watch is that a cache miss in Windows Azure on the virtual machines is fairly expensive. It will go off and grab the cache miss in a 512K buffer. So it can actually be a little bit slow. So you want to be careful if you're using the caching. Make sure to do a lot of performance testing around that. Or you can normally just stay with the no caching, and you get the general performance out of Windows Azure backend storage that tends to work quite well. Now what we want to do here is, so let's say we've got these machines, and we've configured things. Let's go ahead and add to a set of these files. So update on drive C. We'll save this one, and then we'll also look at, as I said, this temporary drive. Let's add a file here. Okay, so in a lab environment, test environment, you're going to set up your machines to configure them as you want. Get to the point where you want to do a snapshot. And you say, hey, I want to save this as my starting environment. Now, because the data is stored in Windows Azure Storage, you have the capability to snapshot those machines very easily. Windows Azure Storage, you can have snapshots on the individual blobs themselves, or you can make a copy. Now, a copy in Windows Azure Storage is almost instantaneous based on the way that Windows Azure Storage is designed. And so making a copy of a drive for your snapshotting purposes is a very quick operation. So what we've done here is I've created a set of scripts for taking a snapshot. It's just a PowerShell script, and we'll publish these up. And we've actually got a set of scripts that we're building to post. Some of these have already been posted. Some of these are coming up here. Takes in a machine, a service. It does a copy of the OS disk. So we're grabbing the URL for the OS disk, the data drives, and then we're just going to make a copy. So let me grab this and kick this off, and I'll show you what's going to happen here. And of course, the demo that worked every time is now, change the directory, here we go. Now we run that. So what it's going to do, it's querying Windows Azure using PowerShell to get the information about the machines and then making a copy into the storage system. So if we come back over here to our storage account and do a refresh, we'll notice there's a snapshot directory. Now we're storing these here. This same capability can be used to move from a staging environment to a production environment, because the Windows Azure copy functionality allows you to not only copy within your account, but you can copy to another account. So if you have a subscription that is for production, another subscription that is for testing, you can use the same functionality to move the machines between the subscriptions. Today, I just did a copy while the machine is running, so you get a crash consistent copy. You could shut down the machines to get a more application consistent copy, depending on what you're needing to do. So if we come back into these machines, and so let's just connect back in here. We'll do some updates. Show that this is going to work. We'll update each of these files. So now if you're running your test, you're running your environment, configuring it as you want. So you made your edit, you made your configuration, you've changed things, and now you want to roll back. So here's where we're going to flip over to the second script here, which is the restore. And so the restore script is just going to take in an additional parameter, which is the container that contains the snapshots. It's going to shut down the virtual machine that's running right now. It's going to copy those drives back over for that virtual machine, and it's going to spin that up. So this is a good point to cover. When you spin up a virtual machine in Windows Azure, you can start from an image that's been sysprepped, and we'll ask more questions to configure that machine as part of the Windows setup process. Or you can start from what we call just a standard disk with an operating system installed. And so that disk with the operating system is really a specialized machine that we're just going to put out to Windows Azure and boot it up. And so by updating and by running this script, and we'll kick this off. Oops. It's going to grab the information about the existing machines. It's going to shut it down and then replace the disk. And this takes a little bit of time, and so we'll come back to this. But this is a great way, using this automation, to revert back in time. You can use this to do a snapshot of a single machine or a whole lab of machines all at once through the scripting environment. Okay, so continuing. So we talked about storage. High availability. It's useful to know you may not be using the high availability features in Windows Azure as part of a testing environment, but as you're doing a production deployment, you really want to understand the notion of our availability sets and some of those features. So we'll talk about that here. This is a version of some of the hardware in Windows Azure, the actual hardware, and what you'll see is there's a set of physical machines in the rack, a set of blade servers, and there's also one PDU for that rack. Not shown here, there's also a top of rack switch on the rack. And so there are specific single points of failures within the Windows Azure data center. And so you want to have your machines be highly available, even though we have single points of failure on that individual rack. And so a Windows Azure data center is not just one rack, but it's many, many racks within the data center spread out. And so what we do is this notion of what we call availability set. So when you define your virtual machines, when you deploy your virtual machines to Windows Azure, you specify these machines are in an availability set. What that does is that tells Windows Azure that those machines are used for effectively a tier of your application. So they may be the web front ends of your application. Another availability set may be your Active Directory domain controllers. And by indicating to Windows Azure that they are an availability set, we automatically spread them across different hardware so that there's no single point of failure. Above the rack in Windows Azure, everything in the networking and power above there is redundant, and so there's no single point of failure above that rack. Now, if these are web front ends, you would also probably put them into a load balance set so the traffic is spread between the machines. This way, if something happens and let's say that the top of rack switch dies, Windows Azure is going to detect that. The load balancer is going to immediately stop sending traffic to that VM. It's going to send the traffic to the other VM. And then the Windows Azure Fabric is monitoring the machines, monitoring the hardware, and when it sees that the machine is no longer giving a heartbeat, that it's alive, it's going to detect that, and it's going to automatically move that to another physical hardware, and then once that machine comes up, the load balancer sees that and starts sending traffic back to the machine. And so you definitely want to use this notion of availability set to make sure you have high availability of your application, both for hardware failures, and then the other place this comes into other scenario this comes into play is when Windows Azure needs to update the underlying operating system or patch the operating system on the nodes. If we need to update the physical hardware, we walk through those availability sets to make sure that we don't take down multiple machines in that availability set together. We keep those machines up. And this was what allows us to give an SLA. So our availability SLA for a production workload is 99.95%. As long as you have 2 instances or more in availability set. Now, when it comes to Windows Azure, one of the things I talked about earlier is this notion of paid by the minute. So in that case where we did with the snapshot and restore, moving back in time, a lot of other platforms would consider that a new virtual machine that's being deployed, and you'd actually pay for 2 virtual machines for that 1 hour or that 1 10-minute period. In Windows Azure, since we're doing this straight at the minute, we're not doing any rounding up, and so you just pay for what you use. So this allows you to do that snapshot restore. It also allows you to do some interesting scenarios as a application template where you have your virtual machine, you have the machine configured as you want, and then you just snapshot it back in time to be the original state after you're running for a while. It also allows you to easily bring it up and down. So some of the load balancing and auto scale functionality that we announced earlier today will leverage the same capability that you bring it up. When you're using it, you pay for the time when that machine is up. When you're done with that machine, you can shut it down, or the auto scaler will do that automatically. So the auto scaler, I didn't get into a lot of detail this morning, but that also builds on that availability set notion, and it auto scales between machines in the availability set. So it brings them up or down based on the auto scale settings, but it uses that same set of availability set for your virtual machines to say that this is that tier and that you can scale between these machines. The other thing, and I actually don't have a slide here, but I just wanted to mention this, is that also on the economic side, we now no longer charge you when the VM is stopped. So earlier, for those of you that we use Windows Azure, if you left the machine, if you stopped the machine, it still stayed deployed into the data center and took up space in the data center, and so we charged you for that machine even if it was in a stop state. Now the default is when you stop your machine, it goes into what we call a deallocated state, and you no longer pay for the compute hours that machine's running. We do maintain the storage, and so your OS drive, your data drives are still maintained in Windows Azure storage, so that when you bring that machine up, all of the state is available as it had before, any state that it committed to disk. In-memory state would need to come back. Also recently, we have changed the usage rights on MSDN. So one of the things that just really was a surprise to me initially is that in MSDN, you didn't have rights to bring those and use that in the cloud. You could use MSDN on-premise, but in the cloud, which was great for dev test, we didn't have that capability. We've recently changed that so the MSDN software can be brought to the cloud with some exceptions. The software that's available for the cloud is primarily the server software. So that any software that's available for licensed mobility on the server side can be used in the cloud. On the client side, it's limited to Visual Studio right now. So that the Windows client is still not licensed and is not available through the MSDN dev test rights. That's something that we're working on, we're looking at, and maybe over time that's going to change as well. We've also changed the way that we do our charging. It used to be if you had your MSDN benefits, you had a plethora of different options and meters that you had. You had 750 small compute hours and maybe 10 gigabytes of data that you could send out of Hong Kong. And trying to use that and figure out where you're going to run over your limit or not was very, very difficult. And so you had to the point where you're running your machines, and then all of a sudden, because you sent too much data out of Hong Kong, your whole subscription would be shut down. We've moved to a Much more simple model where you have a set amount of dollars that you can use across Windows Azure for any of the services. You can very easily look and see how much I'm using of my free credit. And so you've got, depending on the level of your MSDN account, professional is $50 up to ultimate gives you $150. You can use that into Windows Azure. You can see exactly what you're using. You can kind of get a projection of, are you going to make it to the end of the month with that, or are you going to hit the cap? By default, when you deploy an MSDN subscription, it deploys with what we call a spending cap. And so that as soon as you get to the point where you've used your free dollars, it will shut down the subscription. It saves all your data, but it shuts down your VMs, and you can't access the data until the next month when you have the dollars again. And then you come in the next month, and you can spend those back up quite simply. You have the option to take the spending cap off by entering your credit card in there and allowing once you spend the free dollars, to put the remainder on your credit card. That's actually, we'll cover that in a moment. The other thing we've changed is that the price you pay when using an MSDN subscription is commensurate with the way that you would pay for the software on-premise. So when you're using the software on-premise MSDN, you don't pay for Windows Server. You don't pay for SQL Server. It's just part of that MSDN subscription. And so in that same way, when you use your MSDN subscription in the cloud, not only are we charging you a lower rate for the operating system. For example, here, the Windows Server is normally at a 9 cents per core hour price. You only pay 6 cents. What that price is really the price of just the compute cost. It's the same price that we charge for running a Linux operating system in Windows Azure. In addition, any of the software, so the SQL Server, BizTalk Server, those you don't pay for that on a per hour basis either. It's just a flat 6 cents per hour. And so it can be a huge benefit if you look at the cost of if you were trying to develop using the existing platform in the cloud versus what you can do now. The one change, and the one thing to note here if you've used MSDN before, is that MSDN rights in Azure, up until this new offer came out, give you production use rights. And so with all those plethora of meters and kind of that craziness, you could use those for a production service. Now, what we've done here is that we've given customers the ability to stay with the existing offer with all the meters and the production usage rights until this time next year. And so August of 2014 is the deadline to move to a new subscription. You want to go into the portal and click to stay in that existing offer if you have that and you're using it for production use rights. Otherwise, every existing MSDN subscription will move over to the new offer type on August 1st. And if you want to move to the new offer type immediately, again, you can go to the portal and you can click in your accounts and you actually change that to the new offer type immediately and start seeing these benefits of the reduced prices. And so finally, this I just added because we just announced this today. So if you sign up for MSDN, you no longer need a credit card. So you can get that. Thank you. So with that, you just sign up. Your cap is on. You get your $50, $100, $150. And you don't need to worry about a credit card unless you want to take off the spending cap and get that overage charge. So it makes it much, much easier, something we've been pushing for a long time. All right, so let's look a little bit at how this looks in the gallery. So one thing that's important, if you have multiple subscriptions, the portal aggregates subscriptions together. So I'm going to flip over here, and right now I have my internal subscription that I use. I'm going to turn on my MSDN subscription, add this to the portal. Now, this could be you've got your production and your testing subscription. It could be a set of different subscriptions. It is important, though, you want to be careful not to deploy, for example, SQL Server Enterprise that costs you $2 an hour to the wrong subscription for testing purposes. And so we'll show you how this works. Oops. Let me do a refresh here. The portal's a little slow. Uh-oh. A live site bug. This is not good. So we're not loading all of our virtual machines. Okay, so normally what we do here is when you go through and you'd select when you have multiple subscriptions, there's a drop down, and that's going to show you which subscription you're deploying into, whether that's your standard subscriptions or your MSDN benefit subscriptions. And so you really want to pay attention to that when you're doing the deployment. The other piece that I wanted to mention here is that with the preview releases, so Server 2012 R2 preview, the SQL Server 14 on the 2012 preview, those are going to be charged at 6 cents per core hour, whether you're using MSDN or the standard production. That's because those are in a preview release. We don't have full we don't have full support behind that software because of being preview, and so we charge you at the lower rate, whether you're an MSDN or if you're in the full production release. Now, one of the other questions somebody asked earlier was, what if I have a set of MSDN subscriptions across my organization? Maybe I have 10 different users who have MSDN subscriptions. How do I actually share those among the different users? So if you come down in here to settings, you have the notion of administrators. And so you can add administrators to the individual subscriptions to share. In the case of an MSDN subscription, you can add any other user who is an MSDN user to that subscription. As the key point is that any user using the MSDN subscription needs to be an MSDN, have a subscription for that user itself, because MSDN is a per user basis. We don't have the ability yet to be able to combine, and so like say you had those 10 subscriptions at an ultimate level, and so instead you might want to have one subscription with $1,500 versus spreading that. We don't have that ability yet, but by moving the machines, moving the deployments using the copy blob operation, you can move machines between those subscriptions fairly easily. And as we go forward, we're looking at being able to do some combinations, do some more interesting things in that dev test environment for using when there's multiple users. All right. I'm going to try this one more time, and let's just see. All right. That's not going to work. Okay. We're going to come back. So what I would have shown you if the portal was working is the going through and deploying one virtual machine. Many of you have probably already done that. If you were to build out an application one machine at a time, you would find that's just too time consuming. And so you want to use some automation. Now, what we have done working with Microsoft Consulting Services is we've built up a set of PowerShell scripts to deploy a SharePoint environment, Active Directory, SharePoint, and SQL through a set of automation. We've got two initial templates for this. One is highly available SharePoint, and the other is what we call a single machine SharePoint. And so where we have one single server for SQL, single server for Active Directory. These are available in GitHub, and so you can download those, you can use them, you can modify them, you can make changes and update them and submit them back into GitHub so other people can leverage them. The other scripts we'll be adding in a similar manner through GitHub, like the snapshotting scripts. We're going to be building out a set of tools that you can use for automation, for deploying and automating the virtual machines. PowerShell is a very useful thing for automating a lot of the Windows workload, primarily because you can automate Windows Azure with PowerShell. And so you can deploy virtual machines, you can add disks, you can add endpoints, you can configure that through PowerShell. But in addition, you can do remote PowerShell into those machines and then configure the application. So I'll just give you a quick overview of what we've got, and I'll show you some of the scripts for this. So a single virtual machine template, as I mentioned, the SharePoint app and web servers all in one, a SQL box, and an AD box, a very simple little dev farm to put together for SharePoint. The more interesting one is our high availability version. So in our high availability version, there's multiple machines in each tier. So there's 2 web front ends, there's 2 application servers, a SQL server configured in a always-on configuration with a primary and secondary, with a third machine as the witness for the SQL Server tier, and then 2 domain controllers for the Active Directory. Those are all put into one, what we call a cloud service. So the virtual machines go into a cloud service. We also put that into a virtual network. Now, a virtual network does a couple things for you. One, it gives persistent data center addresses for those machines. So when you're using Active Directory, you definitely want to use a virtual network so that you have a consistent IP address for the DCs that are performing as the DNS servers. The virtual network also allows you to connect multiple services together to use the back-end data center network, and we'll show you how that works. Finally, virtual network allows some of the cross-premise connectivity that we'll talk about here in just a moment. So the final thing I wanted to point out on this layout is that there's that load balancing. So we set up a HTTP load balancing on the front end for the web servers, and then another load balance endpoint on the application servers. One thing you'll notice that's not there is that the database servers are not connected through any load balancer. There's no endpoint, so there's no way to contact them from the internet. They are only available within that virtual network. And so that gives you some protection, but then you're going to need to, how you actually manage that, configure that, and we'll talk about that and how we leverage a new technology for that configuration. So the scripts that we have are very simple. So this script here would start off the deployment of that single VM deployment. We have an auto-configure that will configure the devices, the passwords, the usernames in an auto-configured way, or you can configure a lot of this, both what we're showing here on the screen as parameters and in more depth through the configuration file. And we'll show you that in just a moment. So let me dig in. Let me show you these scripts and how you would leverage them. So first we'll look at the directory structure here. Oops. So when the scripts are, when you download them, and actually let me show you, the scripts are available here on Git. So you can just come in here and grab a zip of all of those scripts, and grab them into your directory. The scripts are structured in the notion of there's a set of scripts for each tier, so Active Directory, SharePoint and SQL, and then configuration. And so in the configuration, there's a set of templates for the high availability or single instance, and then there's the files here. And if we actually look at these configuration files, the samples start off with a set of items here. Anything that's in the curly brace is something that you need to either set yourself, or when you use the auto configure, it will choose the most appropriate version naming. So here, the subscription name is based off of the default subscription you've configured in PowerShell on the machine. The starting image, for example, down here, we just look and we find the most recent Windows Server 2012 image for the domain controllers. Same thing for SQL, it's the most recent SQL image, and SharePoint also the same thing. And so you can come in here and you configure as much or as little as you want. If you run the auto generation script, what it's going to do is it comes in here, and here it's found the most recent version. Here I actually forced it. I said, don't create a virtual network. I want to use my own virtual network. And this is the primary way that you can configure those scripts, and then you just run the single command, and that's going to build out those machines. It builds them out, and it takes, for example, a high availability SharePoint. It takes about 4 hours to put together because there's a large number of different machines. Setting up the networking, setting up SharePoint takes a while, but you have a full flexibility in that scripting environment and the configuration to set it up as you want. The result is going to be, if we may be able to see this, but if our machines are still down, I was going to show you. See if this came back yet. Nope, we're still down. Okay. So we're going to dig in, and we're going to show you some of the resulting configuration of those machines. It looks like, let me just see, it looks like the site, let's see if it's still up. So the machines are still up, it's just the management portal that is not working for us right now. All right, we'll flip back over. So now let's talk about how to bring this together. So one of the very interesting, cool technologies that we've just recently announced is what we call point-to-site virtual networks. So once you set up your machines in a virtual network, you have the capability to use a gateway server that can connect site to site. And so when we first released Windows Azure back in, the infrastructure service back in April, we had site-to-site connectivity. So that allowed you to connect to a on-premise VPN device, so you could have, normal VPN connectivity. The challenge with that is you typically have to go through the IT organization. You need to get authorized to put a device on the network and on the internet. And so it can be fairly painful to set up. And if you're just doing dev test, you probably don't have the time or the effort to really want to go through all that process with IT. With point-to-site, it allows you to use that same gateway technology as a VPN from your machine. And so your machine could be within the corporate firewall, like we're showing here, or it could be a machine coming in from home or from working at Starbucks. And it just sets up a VPN connection. It uses standard SSL connections. And so if you're within the corporate environment or wherever you are, you can almost always connect just using port 443. So this gives you a lot of power to just connect directly into Windows Azure. Is one of those things that at Microsoft, our IT organization is a little nervous on how much power that actually gives developers. To me, that normally means that if they're nervous, it's pretty powerful and it's going to be a very useful feature. And so with this, it really allows you to start treating Windows Azure and your machines in Windows Azure as machines as if they were under your desk or in your lab. You have connectivity directly to those machines. I'll show you some of that. But it opens up the power of Windows Azure and the power of those machines to just use them as if they were any standard machine. So let me go over and this demo should work, so we'll see. So what we have here, let's see if the networks are up. Great. So the first thing you're going to do a point-to-site network is you use the virtual network. And so if you're creating a virtual network, just use the dialog here. The first thing here, and I'll just do a demo here. So we've got a demo at build. Your virtual network goes into an affinity group that ties it to a location on one of the Windows Azure data centers. You select, so here you can specify a DNS server. So for example, when we did the SharePoint, it sets up the DNS server as the DCs. If you don't set a DNS server, then it'll use Windows Azure, Windows Azure's DNS servers for you. You can then set up either the site-to-site connectivity using that VPN hardware device, or you can use a Windows Server 2012 Azure VPN device using the RAS functionality of server. But you can select this, configure the point-to-site, and that's what we'll show you here, because it's when you're using it from a developer environment, that tends to be the thing that is very useful. You specify the connectivity for the point-to-site network, and so this is the set of IP ranges that are going to be given to the client machines. So here we'll just set this at a 172 range, and then how big of a subnet you want for the clients. You then configure the rest of the address space. So I'm just going to set up, this is the virtual network space I'm going to set up in Windows Azure. So I use the /8 subnet. If you were doing, for example, when I set this up for the SharePoint, I set a DC subnet, and we set this just a /1, and we don't need a lot of domain controllers, so I just did a /29. Set another subnet, typically for your application servers. That is a /2.2. And then you add a gateway subnet. Now, the gateway is a set of servers that Windows Azure is going to stand up for you. We manage those servers, but that's going to be the termination point from the clients connecting in or the site-to-site VPN connection coming in. It sets up at least 2 servers for you, so you have high availability, the failover between those. You don't need to worry about managing those servers. Windows Azure manages those servers for you. You do pay a per hour charge. I think right now it's at 5 cents for the gateway service for that to be running. So we add the gateway subnet in here. We'll just put this at /3 or .3, sorry. And that's going to build out the virtual network. At the end, we're going to end up with something like this. This is the virtual network that I have for the SharePoint. So we've got our DCs in here. They're in the DC subnet. A lot of other machines in the application subnet. We've uploaded in here from a certificate standpoint the root certificate that is used to create client certificates for authenticating clients. So then you can create a separate client certificate for each client or group of clients that you want to connect, allow that or disallow that in, and so that allows you to cut off anybody from the network if you need to. So let's say you deployed and an employee leaves the company, but they were connecting in before from their home machine. You can remove their access by removing that user's certificate. Then the only thing that you need to do to connect into the client side is to get the VPN package. Now, you can download the 64-bit or the 32-bit package. This package is compatible with Win 7 and Win 8, the VPN client that's built right into Windows. All you're downloading here is configuration. So it's no code on the box, it's just the configuration. We'll download this package here, and then we will install it to the machine for the connectivity. So we're going to run this. What happened here? Let's try that again. Seems like maybe I should be back in the office. It looks like we're having problems on the site. All right. Let me see if I have this in my cache from earlier. Yeah. All right. So this is going to be, so normally what we would have is we would download the script. This would set up our VPN connection, and we'd be able to connect directly in here. Unfortunately, I don't think that's going to do us any good in removing that. All right, so let me just walk you through it. So what would happen by downloading that VPN connection? That's going to set up a connection into the Windows Azure. The client's going to get an IP address from that range that we configured, the 172 range. And at that point in time, your dev machine or wherever you connect the VPN client has full connectivity. And so with this, we're able to connect back into those machines, whether it's SQL Server, the SharePoint server. We can connect directly to those machines, even though they don't have an endpoint on the public internet. And we can configure them. And what it allows us to do then is then we can use all of our tools that we use on-premise for doing development, configuration. You can use things like SQL Explorer to connect to the machine. We can use standard performance counters to download those performance counters. You can use SMB, things that, trying to do SMB over the internet is never going to be possible, or standard file share protocols. But with a VPN connection, you can just really treat it as if it's a machine under your desk. This actually goes to a question I heard earlier, which was how do we actually move data to the database in the cloud? By standing up the SQL server and then having a VPN connection in there, you can use any of the data sync technologies to sync data between an on-premise environment and the cloud directly without going through the public internet. So you can use all those existing tools and functionality. So unfortunately, I'm going to open this up for questions, because the remainder of this, I was actually going to leverage the point-to-site connection, the VPN connection, but without that, I'm going to be a little bit out of luck. So, yes, over here. So the question is, if you're going to test client applications, doing load testing in the cloud, what's the best way to license the client's OS? As of right now, for a large amount of load testing, a lot of people would do that just using server, and so you can certainly do that. For generating load, there's also tools, and I'm not going to get into it here, using TFS Online, generating load tests, and so that's an option for generating load against the back end. But we don't have the ability to upload a client operating system and test the client operating system in Azure today. What you can do is you can test your server side in the back end and run your clients on premise, but we can't run the client there yet. Again, it's not a technical limitation, it's a licensing limitation right now. Okay. Any other questions? Right here. The question is there plans to integrate TFS lab management with IaaS VMs? That's something that we are looking into. We have TFS integrated with our platform as a service, and so it'll do an automatic deployment. Going forward, we're going to be investing both through infrastructure service in Azure and also the Azure Pack on-premise to actually build that out, but it's not there quite yet. Back here? Yes. Right, so the question is, earlier in the demo, we did a snapshot of a running machine, and is that really recommended? So that gives you a snapshot of a crash-consistent snapshot. It would be a little more recommended, especially if you're moving between environments. You'd want to do a shutdown and then do the snapshot. In this demo, is really more for time purposes. I just did the snapshot of the disks themselves. But you can do a shutdown from those scripts and then do the snapshot. So the question is, what if you cannot shut down the machine? There's a couple options there, leveraging VSS integrated solutions. You could call into VSS and do a VSS-based snapshot. That's not something that we really have in the scripting yet. We've been working with the online backup team to actually build out that VSS app integrated snapshot. But it's not there in the scripts that I have right now. The question is, can you not use SCVMM to snapshot the machines? SCVMM utilizes functionality in the hypervisor that we don't have available in the Windows Azure hypervisor. Or more specifically, it's available, but what you have to do is, for that to work, you connect directly to the hypervisor. In Windows Azure, because of it's multi-tenant, we don't let direct connections coming into the hypervisor, and so we don't have that in place yet. It is something we're working on. Question over here.
Yeah, I was wondering if you have plans to enable Azure Active Directory to support full domain controller functions so that I don't have to spin up PCs?
Yeah, so the question is, will Windows Azure Active Directory give you the full domain functionality, the machine join functionality, so I don't need to worry about spinning up the Active Directory in the cloud? That I think the team's working on. That's outside of the area that I work on. We've been partnering with those guys. So I can't really say what's the direction for Windows Azure Active Directory. Today, Azure Active Directory is user authentication and not machine authentication. So if you're running SharePoint or if you're running SQL using Windows Integrated Auth, you do need a proper Active Directory in the cloud, unfortunately. Question back here.
Yeah, you had stated that if a machine was in the stop state, that we wouldn't be charged for it. If the machine is in a sleeping state or in like a pause state or any other state, are we charged for that?
Oh, we got that on the recording. So the statement is, if we're stopped, the statement we weren't going to charge you for. What happens here, and if we had the portal, I would be able to show you. There's two forms of stop directly in the platform. It's a stop machine where either you stop from within the VM or you did a legacy version of stop that keeps it allocated. If it's still allocated, Windows Azure is going to charge you for that. And so like if you go to the machine and you do a shutdown from within, it stays allocated out on those machines because we really can't tell if it's just a reboot or a proper shutdown. Where you're not going to be charged is when you go from within either the REST APIs or the portal and say stop in the portal. Now, the portal now would by default do the unallocated. What that does is it takes that machine and it pulls it out of the fabric controllers. It frees up those processor cores, and so you're no longer using those and just maintains the storage on the back end. And so once we do that, then you're not charged for it because you're no longer taking any of the processor cores. So in the case of if you're not utilizing the machine a lot, it's went into its own sleep state. Probably the best thing to do there is to look at some of the functionality with the auto scale, where it actually monitors the CPU and have it automatically scale those down when you're not using them. So you deploy them into an availability set. Let's say deploy 3, 4, 5, 6 of those. Set up the auto scale to monitor CPU, and when those machines are low on the CPU, below the threshold that you set, the platform will automatically deallocate those for you. That will give you that stop deallocated scenario. If your machines are stopped, it should give you that same functionality where it says, hey, the CPU is really not necessary, is not being used here, and it would deallocate those. So that's what you'd want to use in that scenario.
Thank you.
All right, one last question, and we'll wrap it up. Oh, the question is, what's the restart time coming from a stop deallocated to a fully running system? That time is equivalent to doing a deployment, not going through setup, but just a disk-based deployment. And so it ends up being about 90 seconds to maybe 2 minutes, depending. It does vary a little bit. All right, take one more. Yeah, back here. Yeah, the question is, how is the licensing, specifically for MSDN, where you have the 50, 100, 150 done? So MSDN is licensed per user, and so that subscription is for that user. The way that we structure it, though, is that if you have other users that are MSDN users, they can each set up their own MSDN subscription, or benefit subscription, and then they can add other MSDN users to that as administrators to that environment and leverage that. It's not a technical block in this case, but it's just when you have an MSDN, you're only allowed to share that software with other MSDN users. The same thing goes, so if you have an MSDN-based account, you're only able to share that account with other MSDN users. And again, it's for dev test purposes. The question is, it covers configuration and management. Essentially, the administration of that is administrating, spinning up, shutting down, adding disks to the machine. Once your machine is spun up, you can add anybody that you want in there as a local administrator. Again, it's modulo the licensing for MSDN. I don't really want to get into too much details there, but yeah. Okay, so I want to thank everybody for their time. I'll be up here for some other questions, and again, I do apologize on our live side. I'm going to blame this on VJ here. Why aren't we? What's going on here, man? It's working for you? Okay.